Okay, so here we have our objective 2 from Unit 1, translation notes. So here we're going to be graphing translations. In other words, we're going to be moving our graphs around now. Now, everything on our worksheet on the notes is already in y equals form or f of x equals form. But like it says here, sometimes when it's not in y equals form, like this equation here, we want to do a little manipulation to get it in y equals form. So here we got the algebra steps you can copy down if you want to. We want our equations in this form so we can easier see the translation. But we'll see examples later. That's just if you want to have that. All right, so first of all, f of x plus a is a translation of f of x where? Now, what can we rename f of x if we want to? Instead of f of x, well, we can call that thing y. So this is like adding something to our y values. My y value changes how far up or down I go. So if I add something to my y values, well, that's going to move my equation up, well, whatever a is. Okay? If I subtract from my y values, in other words, if we subtract from f of x, that's going to move our equation down, whatever a is. Okay, so adding or subtracting something to your y values, which most times is going to be at the end of your equation, is going to move our function up or down. And if we add or subtract something from the x's, well, then that's going to move it side to side. If I add something to my x's, now it's kind of the opposite of the y values. If I add something to my x's, that actually moves my equation to the left. So if I add a to my x's, it's going to move it left, whatever a is. And if I subtract something from my x's, it's going to move it to the right, whatever a is. All right, and then let's look at some examples down here. Okay, now this first whole row here, we've got f of x, and then they give us the graph. They don't give us the equation, just the graph. Next, f of x equals 3x, and then there's that graph, and then that graph for that function, that graph for that function, that graph for that function. So these are just our original functions. They're already drawn for us, so not much to do there. Okay, and then below each of these graphs, well, they've changed the equation a little bit, and then we got to see, okay, what's that new graph going to look like? So they graph the original function again for us here, and then we want to graph the new function and see how that thing moves. So if f of x is this funny looking graph over here, well, what's f of x plus 3 going to do? In other words, if I add 3 to my y values, how is that going to change my graph? Well, let's just focus on the y values. This point has a y value of 2. If I add 3 to that, it's going to be at a y value of 5. This point down here has a y value of negative 2. If I add 3 to that, it's going to be a y value of positive 1. This has a y value of positive 1. If I add 3 to that, it's going to be a positive 4. And then this point has a y value of negative 1. If I add 3 to that, it's going to be at positive 2. So then I got these new points, and if I connect the dots, let's see, these first two are connected by a line, and then a little bit of a curve up, and then a little curve down. Okay, well, then that gives me my new graph. So in other words, when I add 3 to my y values to the end of my function, it's going to shift my graph up 3. What will that look like for the next graph? Well, since we know it's going to look the same as this graph, just shifted up 3, an easy way to graph that is just take each point and move it up 3 spaces. So this point at 0, 0 is going to be moved up to 0, 3. And this point at 1, 3 is going to be moved up to 1, 4. I'm sorry, 1, 6. And then I can draw my new line. And it should be just like the other graph, just moved up 3 spaces. Okay, same thing for the parabolas. Since I know that this function looks like that, well, this function is the same thing. It's just going to be moved up 3. So take each point, move it up 3. So 1, 2, 3, 1, 2, 3, and 1, 2, 3. And we get those 3 new points. Try to make them a little bigger so you can see. And then connect the dots, and you'll have your new parabola. So again, it should have the same shape. It should be opening the same direction. It's just going to be shifted up 3. Same thing here, this graph. Move each point up 3, up 3, and up 3. And then once you have those points shifted, then you can draw your new absolute value function. Okay. Now, if you're not sure if this is correct, especially since on these ones we have the equation, go ahead and make a table of x and y values and then plug in, x is 0. You'll see the point moves up here. For example, you can do that in our head. If I plug in x is 0, 0 squared is 0, times 3 is 0, plus 3 is 3. So when x is 0, y is 3. Yeah, that worked out. And it'll always work out. But it's easier just to use this whole shifting idea. We know y equals 3 to the x looks like this. So y equals 3 to the x plus 3. Well, that's going to move these points up 3. Now, the one extra thing that you probably want to do with the exponential functions, since the x-axis in this case is our asymptote, which is just our boundary line that our line never crosses. Since we're shifting it up, we might want to shift our asymptote up 3 as well. So we're going to go up 1, 2, 3, and then I'm just going to draw a dotted horizontal line. And then that's my new asymptote. That's the line that my graph's not going to cross. And now I can draw this thing pretty much like it was before, just shifted up 3. So what happened on all these functions when we added 3 to the end of our equation? Well, it was shifted up 3 units, or just shifted up 3 is fine. Okay. All right, on the next row. Well, again, we have our same equation f of x. Then now, instead of adding 3 to our equation, we're going to subtract 4 from it. Okay, now we don't need to do all these examples again, but here if we add 3 to our equation and it shifts it up 3 units, well, what do you think is going to happen when we subtract 4 for all of these graphs? Well, these are all going to be shifted down 4. So we're just going to put shift down 4 over in the description box. And if you have time and you want to, you can move all those points down 4 and draw your new graphs, but it's not really necessary. Let's just do this one though, because again, anytime we're shifting vertically up or down, we probably want to move our asymptote. So here, I want to move my asymptote down 4 units. So then I'm going to draw a new horizontal line down 4, and then I can move each of these points down 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. And then I can draw that new curve. Okay, so something about like that. Okay, but again, we don't have to plug in points. We don't have to do a whole bunch of new stuff. If we know how this graph is shifted, that's going to save us a lot of time. Okay. All right, on the back side. And again, we're not going to do every example here. We're mainly focusing on the description, what's happening to these new graphs. Okay, so on these functions, we're taking our original x value and we're adding 4 to it. Now remember, the x is kind of the opposite of what you'd think. When you add something to the x's, that's going to move it to the left. When you subtract something from the x's, that's going to move it to the right. Okay, so let's do the first graph, for example. If I add 4 to my x's, that's going to take each point and move it to the left 4 units. So then I'm going to take this point, move it left 4. So 1, 2, 3, 4, right on the edge. Take this point, move it left 4. 1, 2, 3, 4. Take this point, move it left 4. Take that point, move it left 4. Okay, and then next I just want to connect the dots the same way they are here. So the first two have a line connecting them. And then we got a curve that's kind of swooping up. And then one that kind of drops down, comes just barely back up to that last point. So then there is our new curve for f of x plus 4. Okay, let's do one more. Let's do the parabola. Okay, what's going to happen to this parabola if we took our x value and added 4 to it? Well, it's going to move to the left 4. So just take each of these 3 plotted points and move them left 4 units. So we've got 1, 2, 3, 4, 3, 4, 1, 2, 3, 4. And then once we have those 3 points plotted, we can draw our parabola. Just going to look about like that. And then we're done with that graph. And same thing with these other ones. We would just take each of the plotted points and move them left 4. Now, would we need to draw a new asymptote if we move this thing left 4? Well, no, we can move it as far left or right as we want to. That's not going to change the asymptote. The asymptote is only going to change when we move it up or down. So what happens to all of these graphs when we add 4 to the x values? Well, they are all shifted left 4. Okay. All right, next, what happens if we subtract 3 from our x's in each of these equations? Well, it's going to do the same thing for each graph. It's going to shift it where? Well, it's going to shift to the right 3. Okay, let's do that to one of our graphs. Let's do the, how about the exponential function? So if I take each of these points, 1, 2, 3, 1, 2, 3, and shift them to the right, and again, I don't need to shift my asymptote because moving it right 3, well, it's still that same line. And then I can draw my new curve. Okay, so it's going to look something about like that. All right. Now, we don't have to do just one of these 4 things to each of these graphs. You can do more than one. Okay, so our next 2 rows, we've got a couple things happening. We're adding 3 to the x's, and we're subtracting 2 from the y's in all of these equations. Okay, well, just think about it one thing at a time. What is adding 3 to our x's going to do? Well, it's going to move it to the left 3. What is subtracting 2 from the y's going to do? Well, it's going to move it down 2. So 2 things are happening here. We are shifting. So we're going to shift left 3 and down 2. Okay, and if we shift left 3 and down 2, then I just want to take each of those points and move them left 3 spaces and down 2 spaces. Let's do it to the, how about the absolute value function? So I just want to take each of these 3 points, move them left 3 and down 2. So starting here, 1, 2, 3, 1, 2. It's going to put me here. Let's go here next. 1, 2, 3, 1, 2. And 1, 2, 3, 1, 2. It's going to put me right there. That gives me those 3 points, and then I can draw that new absolute value function. So we don't have to plug in a bunch of points. We don't have to do much work at all. We just got to move that graph. And it still has the same slope. The slope is still 3 for each of these points. The graph looks the same. It's the same width. It's opening the same direction. It's just moved a little bit. Okay. All right, and then the last row, what happens to these points? Okay. Well, since we're subtracting 4 from the x's, that's going to move us to the right 4. And since we're adding 2 to the y's, that's going to move us up 2. So here we're going to shift right 4 and up 2. Right 4 and up 2. And let's just do one of these graphs. Let's do the exponential functions because these are the trickiest ones because of that asymptote. Okay. Now, first of all, since we're moving up 2, then we're going to have a new asymptote at the line y equals 2. So I'm going to draw that dotted line up 2 from where it was originally. And then I'm just going to take both of these points, move them right 4 and up 2. So let's see, 1, 2, 3, 4, 1, 2. And 1, 2, 3, 4, 1, 2. And you know, once you move one point, you can say, okay, the other points over 1 and up 2, over 1 up 2. If that's faster, that's fine. Okay? And then we can draw our curve. It's going to look something about like that. Okay? And then that's the first part of the notes. We'll get to the next page in just a second.